My name is Martin Brunskov. Welcome to this tech demo of using the OASC MIMs to scale your digital services. If you read this guide, a guide to synchronicity, if you have seen the animations, probably you're thinking, that's a great idea, but how does it actually work? Don't ask me, ask Thomas, who will now take you through a tech demo of how to use the OASC MIMs.
Hi, welcome. My name is Thomas Gilbert and I'm from the Alexandra Insitute, and I'm here to show you how to scale the synchronicity framework with the OASC MIMs. I will conclude with a live demonstration of how to spin up an entire platform and use it to feed data from legacy systems into the synchronicity marketplace. Now first, let's talk about architecture and MIMs. What are they? Well, the architecture we use in synchronicity is a standard architecture you see anywhere else. But what we've done in synchronicity is to distill the interoperability points, and these are now becoming MIMs with the OASC. So we have 3 MIMs, and I will demonstrate them all today. The first one is about context management and APIs. We'll be using a context broker for this. The second one is about open data models, and we'll be using some NGSI-LD data models to demonstrate. And the final one is the ecosystem transaction management framework, and we'll be using a marketplace for this. So what we'll be seeing today? Well, I have devised a flow that I'd like to demonstrate and walk through with you guys. We'll be ingesting data, CSV, JSON data from a legacy system. This will be, in our case, a CCAN database. It could be MQTT, Kafka, any other way of ingesting data. But the basic thing is it's unstructured or semi-structured. What we'll be doing with it is feed it into an atomic service that will transform this data into NGSI. After we've done that, we'll actually inspect it, what is this data, and then we'll validate it using NGSI schemas. So we know whatever comes out of this atomic service is correct, and we can use it going forwards in our flow. So once we've had this fantastic data, we'll put it into context management APIs. That means we'll be able to query it. We'll have a language, expressive language, to query it, use geoqueries, ask about values, where is this data, and that's the context management APIs. And we also have an atomic service for machine learning and analytics. And what this is able to do is you receive data directly as long as it's NGSI, or it can subscribe and fetch data itself from a context broker. So once we've achieved this, we also want to visualize data, and we have atomic services for this, for mapping, visualization, graphing, and stuff like that. The final thing we'll show is the marketplace. We will take data, NGSI data, from the context management system and feed it into a data marketplace. So what is this data we're talking about? Well, I found a data set openly available in the city of Aarhus about traffic, and I thought that would be an interesting case to show. So this is what we found. On the open data platform for Aarhus, there is real-time traffic data about traffic flow in the city of Aarhus. The problem with it is you can't really query it, you just get a dump of data in a comma-separated format. So what we want to do is transform this data, make it accessible, use machine learning frameworks to predict traffic flow, and then put it into the marketplace. For this demo, we'll be using Node-RED. So Node-RED is not really important, it's just a visual framework for demonstrating flows, and we can connect various components, show with a little bit of code, and actually have our entire platform up and running. So if everything goes well, what you will see is this type of flow with lots of boxes, but they all represent some sort of either service or node with a little bit of code behind it. But this is what the entire platform will look like at the end. We'll be using atomic services, as I said, and some of them are just plugins for example, Node-RED. The one I like to talk about is the one that converts data. It's a simple component that, given a schema and a transformation file, it can transform any data to any format, and we'll be using it to make and generate our NGSI code. We'll be using an atomic service for prediction. This is the traffic flow estimator atomic service, which actually provides machine learning capabilities packaged really neatly. So you don't actually need to understand how they work. You just need to feed it NGSI data, and then you can query for predictions afterwards. The one that we'll be using needs about 6 hours of data before it will give you predictions, but it's the same component, and it is based on the ELK stack. Another thing I'd like to demonstrate is an atomic service for visualization. Now, we've built in the project plugins for Grafana, which will show on a map where these NGSI entities are located. And finally, we'll be putting data into a marketplace. So, off to the demo. Thank you very much. I will spin up a Node-RED instance, and I'll use a terminal for that. I have prepared a quick command to do that. And this is not a blank piece of paper. I have done a bit of work to parse the data from the CCAN instance. I will show you now. This is what it looks like. So the boring stuff about looking into CCAN and parsing the comma-separated files, I've already done that work. So if I look at the debug output of this flow, you should see data arriving from the open data platform of the city of Aarhus. There we go. So data is flowing now, and this data is not real time, it's near real time, or whatever you want to call it. It's updated every 3-4 minutes. But you see you have data here. This is a timestamp from when it was recovered, how many vehicles have passed, average speed, and some coordinates. This is not a format that we can actually share with anybody else because this is the random format from this specific platform. What we want to do now is transform this into NGSI, and we have an atomic service for that. Which is a Node-RED flow. This is a transformer node. I will just give it a nice name. Go. And also tell it where to find the transformation. And this is the URL for that. So what this does, and I'll show you the this one. So what we want to build is traffic flow observed from this comma-separated format. And all the data models that we've been using are shared data models that are open sourced, and what you can find them online. And this is the specific one we want to generate. And we need to map it between the parameters in the legacy system with these NGSI ones. And I've prepared a formatting, and this is what it looks like. This is the transformation into NGSI using the values from the comma-separated file. And if I link this to my data, like so, what you should see now is that the data from the CCAN instance will flow through my new component here and output into the terminal. And what you see here is actually NGSI data. So what is the next step? Well, from this data, I would like to push it into a machine learning framework. And luckily, the machine learning component just accepts a REST interface, so we can just post this data directly into the machine learning framework. I will import from my clipboard. There we go. I will, instead of sending the data to the output, post it directly into the machine learning framework. So now what we want to do is use the context management APIs. And what we'll be doing is starting up the Orion context broker. And let me get started on that. There we go. What we did beforehand was actually follow the guide online, how to start the context broker. And you can find these resources online. Now it's started. Let me paste in some more nodes. There we go. Now you can see what we're doing here is that we're taking the normalized output and putting it through another transformation node that transforms it into the key values format. After that, what we do with this node is we resolve it. We look at what is the data, what type of data is it, and then we look at how to validate the schema, and that's what the next component does. So what comes out of this component is actually validated NGSI data. Now we want to add the context broker, and that's a component available here. There we go. So once we run this flow, we'll actually have data flowing into the context management APIs as well. So the final thing we want to do for this demonstration is also put data into the marketplace. We have already a marketplace running. This is the Open Data Market Exchange. And on my profile, you'll see that I have already pre-created a traffic flow package for NGSI. And what we need to do is use this URL, have a generated token, and put this into our Node-RED flows. So now that we've created our credentials with the marketplace, what we want to do is add nodes to the Node-RED schema that publish the data to the marketplace. And this is really simple because this is also just a REST API. So what we do is import from our clipboard. We change the credentials that we've just copied from the website. This is it. Done, and we're ready. And what this does is, aside from feeding data into the context broker that we have locally, we also just want to put this data into the marketplace. So now the final thing I want to show is that now that we're using standard APIs, standard data models, and a marketplace, what we can do is actually ingest other data into this flow really, really easily. And what we found is that on the marketplace, what we have is data that uses the same data models. And we found, for example, that Porto is also publishing traffic flow events into their marketplace. So what we can do is actually copy data from their marketplace and use it in our flows and feed this data into the machine learning component. Let's just try that out as well. So what this does is, at regular time intervals, for example, every minute, it will ask the Open Data Marketplace, give me all your data and send this. Let's send this into our machine learning framework. There we go. And that's all that's needed actually to complete the entire platform. So now I've tidied up my flow, had it running, and what do we do with the data? Well, the final thing I want to show you is something about visualization. And what we've developed is atomic services for visualization on a map, for example. So we've built a plugin that allows you to visualize traffic flow on in Grafana on the map. But if you don't want to use Grafana, you can still use exactly the same code in your own applications. And I have a demonstration here that shows you something about the traffic flow in the municipality of Aarhus. And this is the traffic flow since August 2019. You can see congestion points, especially within the inner city, and the lights. Thank you very much.
Thanks, Thomas. I think we can be really happy that you have done all of this work with the colleagues for years so that everyone else can actually spin up the framework to use the OASC MIMs in 20 minutes. Now, what do you do when you have a service, when you have 3 services, when you have 5 services? How do you sell them? How do you share them? How do you get other people's work? Let's invite Gert from OASC to tell us about the OASC Catalogue.
Hello, everybody. I'm Gert De Tant from OASC. I'm technical architect at OASC, and I want to talk to you about the OASC Catalogue and certification. Thomas has shown a really great demo on how you could get data into the context management, the MIM1, and how you can actually query the context management and show solutions and build solutions on top of that. But imagine that you're a solution provider and you build some solutions on top of the MIM1 and you're using the data models MIM2. How do you go about in selling that to cities? And how do cities acquire those solutions? That's where the catalog and the certification come into place. How do we see it work? How do we see that work? Now, the certification, what we want to do there is really enable cities to procure not only alone, but also in group solutions that are interoperable with the MIMs. And And how do we make sure they are interoperable? We will certify them. So the solutions that are running on top of the MIMS or providing data to the MIMS will be tested by very nimble tests, lightweight approaches, where we test their interoperability, see if they talk to the API, and if they use the right data models. How we test them will be determined together by the cities. It will be fulfilled by the solution providers, and it will be tested by partners of OASC. When important, the certification will happen by OASC itself. So we will certify that solutions are okay and that they run on the platforms that are deployed in the different cities. How they will exactly work? For example, imagine you have an RFP out there where you request for a solution and it has to be OASC compliant. It will refer to a MIM. For example, it will refer to the data has to be to come from the context management, and it has to, for example, be a waste management model. We will build a test on top of that, a POE test, which actually checks that interoperability. We will do it. We will test it out with real platforms, but done by the partners. And then that test will validate if your solution is certified or not. We will give it a stamp, and then you can actually show that stamp on your solution. That's one thing. So you have your solution certified, but how do you broadcast that to all the cities? Therefore, we introduced the catalog. What is the catalog? It provides transparency to cities on how they are solving their problems. So imagine a city has a case where they really solved a mobility issue in their city with some kind of solutions. How they can really put that in the catalog and tell, this is how we solve it, and we use these solutions, these components to solve that. So the solutions are per city broken down into partners that did the development and did the deployment of the hardware and the components, the services, the data models that were used, the data that actually was used, from which broker it was used, algorithms, protocols, and even KPIs on how the things were measured and how they went about on doing the stuff. We use the IoT Catalog as a basis for that, which was created in the IOF program. So how will the roadmap look like of the catalog? So we presented the first prototype at the Connected Smart Cities and Communities event at the 23rd of January. And now we have a mini PPP running until June 2020. On the World Government Summit in Dubai in October 2020, we will have the UN Global Mandate there, and we will have the SDG 11 Global Council, where together with UN Habitat we will show the catalog solution. Together we will build a global repository of certified and implementable solutions by cities for cities. So cities will be able to use this catalog as a go-by to find solutions for their challenges they have and to get into contact with the different solution providers. And solution providers can enter into the catalog if they have a certified solution to really show their solutions towards all the cities. It will be a subset of different other repositories. So we won't be the only repository out there, but we will direct to other repositories like the repositories from Fireware, Amazon AWS, Be Smart City, and Microsoft Azure, for example. A small demo on how it looks like. If we go into the website, it's oasc.iotcatalog.com. And imagine that I'm a city and I just want to look in what kind of case studies there are, and I'm looking for something specific. So here I have my drop down where I can see products, case studies, value propositions, urban challenges, components of the solutions, platforms, even learning stuff that cities did, or even stores where products are available. But imagine I'm looking for a specific case study. I can open the case studies and I have my complete list of case studies. Imagine I have a case about city farming. I really want to know how I can solve city farming in my city. I can open the case. If I click on it, I see the case descriptive. I see a small description on what that case is, what it does, what it happened. I see the regions where it was implemented in a summary. So kind of the cities where things happened. And then I can go into depth into that case. So I see, for example, this was done in Dronten and Eindhoven. In Eindhoven, I can see how many square meters there were planted. What they actually did was regarding vegetables. But I can go even deeper. For example, what was the team? And how can I contact the team that built the solution? Because imagine that I like that solution. I wanted to contact the team to see what did they do, how can we work together, and what are the things that we can do. It also handles all the value propositions that are in that case. So what did we try to tackle? What were the urban challenges? What are functions? What are targets? And if you click on one, for example, you want to increase yields, you see all the things that are connected to it. So you can go into depth and browse the case on how you can actually tackle your problems. And of course, linked to that are all the solutions. And the solutions are really broken down in the different components. So it's not only the systems, the software, but also the hardware and all the things that you need to really get to that solution and to really acquire and have that solution in your city. Imagine, and in the future, this will be then OASC certified. So you will know that these solutions run on your platform and that you can easily integrate them on your city. You also have some photos of the solutions. So that's where I want to conclude on the catalog and the certification. I think this will enable cities to really have solutions for their problems and to really open the market towards providers and cities. Thank you.
What we've seen now presented by Thomas, by Gert, is how technically you can spin up a whole platform, a whole framework to deploy in a city or community of any size, and how you develop and deploy services on top of that. The OASC Minimal Interoperability Mechanisms makes this possible, not just technically, which is kind of the simple part of this, but also commercially, organizationally, and practically. This means that instead of going to the market and buying technology, the catalog, that's the vision, will enable you to buy impact. This is still work in progress, and for sure, bits and pieces are still coming together. But what we have seen now with the SynchroniCity validation of the OASC vision is really how we build on standards together, both sides of the market, to make the best of technology for our cities and communities. Thanks for watching, and we hope that you will engage and help develop this approach.